There are lots of videos out there on preparing elemental bromine, so we thought we'd do something slightly different. We'll demonstrate 2 different ways to prepare a solution of bromine in dichloromethane, both using ammonium persulfate as the oxidizing agent. First, measure out 100 grams of sodium bromide. Put this in the beaker and add a stir bar. Place this on a hot plate and add boiling water until you have around 130 ml of solution. Then switch on the stirring and stir to dissolve. You should end up with a clear solution quite rapidly. Set up the 500 ml flask equipped with a stir bar, preferably somewhere equipped with good ventilation. Add the bromide solution to the flask. Now for the oxidizing agent. Weigh out 125 grams of ammonium persulfate. Persulfate is an unusual oxidizing agent in that it doesn't require acidification. However, it operates in an unusual mechanism which we think is radical initiated. Again, add a stirred bar and place on the stirred plate. Add boiling water to the persulfate and with stirring allow this to form a warm saturated solution. Take a sniff of the air near to the beaker. That unusual fresh smell. That's a small amount of ozone being produced. You should end up with 175 to 200 ml of warm saturated solution. Now set up the flask containing the bromide solution on a stirred plate, and equipped with an efficient reflux condenser running ice-cold water. The ice is important to avoid losses. Now around between a third and half of the persulfate solution into the flask through the top of the condenser. You will immediately see the color change, and rapidly see an orange vapor in the flask due to bromine being produced. The mixture rapidly heats up, and after just a few minutes will start to bubble and reflux. You can see why the ice-cold water is important, and why using ventilation is essential. Although not much bromine escapes through the condenser, even a small amount is very unpleasant. After about 5 minutes this first reaction dies down. Make sure that stirring is vigorous, and slowly add the remainder of the persulfate solution in small portions. The solution will reflux and bubble again after each. You'll notice the color of the solution becoming darker and darker. Here we are on complete addition. Continue stirring and allow the mixture to continue to react and slowly cool to room temperature. This may take a while due to the reaction slowly continuing. You'll continue to see some reflux for a while, and it takes about 2 hours to cool completely. Momentarily stopping stirring, you can see a layer of liquid bromine forming in the bottom of the flask. The flask is now at around 35 to 40 degrees C. So we can add our solvent. First top up the condenser cooling water with ice to get it nice and cold again. Now measure out 50 ml of dichloromethane. Add this to the flask through the condenser. As it goes in you'll see the bromine dissolving and the fumes dissipate. At this temperature dichloromethane will still boil very slightly, so be prepared for the mixture to bubble a bit and reflux for a few minutes. Now apply a cold pack or an ice bath and cool the flask down as much as you can. Once it's cool and the vapors have reduced you can dismantle the apparatus and stopper the flask. Chill this down for an hour until it's very cold. Now chill down a separating funnel in the fridge so that it's cold. Check the stopcock carefully and make sure it's able to move, but quite tight. Now pour in the chilled mixture. The bromine and dichloromethane mixture is very dense, and has a habit of sneaking through the stopcock, so be careful here. Separate the bottom layer into a weighed container bottle. Now, to make life easier and less toxic cleaning out the apparatus, make up a solution of around 10 grams of sodium thiosulfate crystals in water. Add some of this to the separating funnel and to the reaction flask to neutralize any residual bromine. And here's our product: 55 ml of bromine dissolved in dichloromethane, which weighs 98 grams in total. Doing some maths tells us that this contains between 40 and 45 grams of bromine, which is an approximate yield of around 55% plus or minus 5% on the starting bromide. This is typical, and although you can get higher yields by doing more careful extraction of the reaction mixture, the exposure risk to toxic bromine isn't really worth it. A quick word on storage. This stuff eats through or penetrates virtually any plastic, including the plasticizers used in most PTFE. The best option is to use a professional quality bottle, but expect the cap to be destroyed over time. Store this in the fridge in order to minimize vapor, and put the bottle inside a tied plastic bag containing a paper towel rack containing sodium thiosulfate crystals. This should minimize any external exposure. The solution is not as powerfully reactive as pure liquid bromine. Here's some zinc metal powder. There's no vigorous reaction, and this is the same using finely powdered aluminium. Okay, we promised another way to do this, so here's the alternative. Weigh out about 20 grams of sodium bromide. This time make into a more dilute solution using 50 ml of water. Take the resulting solution and place it into a bottle with a tight-fitting cap. Now weigh out 25 grams of ammonium persulfate and dissolve this in 50 to 60 ml of water. Dissolving will take some stirring because the solution will cool as the crystals go into solution. Now add this to the bottle containing the sodium bromide solution. You'll see a yellow color like before, but the reaction is much slower this time due to the decreased concentration of reactants. Don't put the lid on yet. Leave the bottle for a good 10 to 15 minutes as a safety precaution. If you got your measurements wrong, then you could have a big problem if you sealed up the bottle now. We put a thermometer in and recorded the temperature. The speed of the reaction got the mixture became slightly warm, but no more. We also checked the safety of heating this mixture by placing in the microwave and heating to around 60 degrees C. No vigorous reaction occurred. Now put a cap on the bottle and leave it in a secure place, preferably with good ventilation. Slowly you'll see the reaction taking place, and after about 24 hours the contents look like this. At this point the reaction will still continue for up to a week to produce bromine, but we can now add some dichloromethane at any time we want to extract the bromine out of the mixture. Here's a little dichloromethane. Like before, with some shaking of the mixture, the bromine goes into solution in the bottom layer, which can be extracted using the pipette as needed. It's not a quantitative method, but this is simple and easy way to get a useful bromine solution for qualitative or demonstration purposes. And that's it. We find that overall the first method is a useful alternative to messy distillation, given that bromine in dichloromethane is just as useful in organic synthesis. Stay tuned and stay safe with bromine.